All right. Hello and welcome to another monthly Unicorn Dispatch Live. Yeah, apparently we do this. We're surprised we're going live too, both of us. Whoa! Bryson and Jake's excellent adventure starting now. I'm your host, Bryson Bort, the founder and CEO of Scythe, and I am joined by a longtime friend, Jake Williams.
How's it going?
Cliche to say he needs no introduction, but he needs no introduction. So let's get to it. Topic for today, artificial intelligence. I picked this for two reasons. One is, of course, like anybody, I know it's going to fill the seats because so many people are interested in it. And I think a lot of that interest is a combination of morbid curiosity and what the hell is it actually, which is the second part of what we're going to be covering, which is what the hell is it actually? What is it? What does it mean? And more importantly, what can we do with it and what can't we do with it? What are the real expectations? Because it has captured everyone's attention. But like a lot of these things, we get the flash and pan, the pan of the attention. But what are we going to do? So with that set up, Jake, what is artificial intelligence? Why are we here? What mistakes in life have the machines led us to?
What is artificial intelligence, right? I mean, like, I feel like you could ask about 10 different people that and get about 10 different answers. But generally, gosh, I can't even use the word generally because then we get an AGI, artificial general.
You're not generatively, you're just
yes. Generically, artificial intelligence is really automating functions that humans traditionally would do using some type of reasoning, algorithmic reasoning. And so one of the kind of hallmarks of AI versus just a traditional algorithm, is some level of ability to be adaptive, right? So whether that's image classification, right, for instance, whether that's and some are going to argue that's a machine learning tool. I'm not going to split the hairs between machine learning and artificial intelligence because I don't find it useful. Whether it's a sentiment analysis, figuring out like, is this customer review positive or negative, right? Kind of thing. Feature extraction. Right? We're doing a bunch of that with third-party risk management. Somebody sends me a SOC 2 report or a pen test report. Like, yes, we requested it, but I'm only interested in about 1% of it. Getting to the usable 1%, right, can be problematic. And so dozens of different use cases out there, and we could spend hours talking about all of them.
Just an audio thing. Your audio is kind of cutting in and out. I don't know if it's where your microphone is compared to where you are.
Yeah, it's probably where my mic's at. Let's see. Where's my gain button? Here.
So while you're doing that, I'm going to give you my definition because
sure.
This is how I've been explaining artificial intelligence for years. And first, the way I like to start with it is within the perspective of what its problems are. So, I mean, artificial intelligence is essentially just a whole lot of math to make something look like more human-like. Because I got this question the other day, they're like, what was the difference between Siri back in like 2010 and like artificial intelligence today, right? Because I could ask Siri things, and this is where,
yeah.
Jump in?
No, go for it, please.
Right. And this is where folks have confused the natural language processing, which is the ability to interpret words, turn them into sentences, turn those sentences into concepts that a computer can ingest, query, and do something with. Well, NLP has been around for a little bit. In fact, back in the 90s, I took a computer science class called Functions, where we looked at the functions of language, because again, it is things with meaning compared with others, give other meaning, and now you extrapolate. This is the human computer, what we have built up naturally over time. And to today, now where I'm able to, back where Siri 15 years ago could take something and do a simple query, now we have the ability to take that information and programmatically generate something. So my favorite explanation for understanding AI and its risk is I've been doing this at talks for years, is the racist soap dispenser. And you can go and Google it. There's a YouTube video, the racist soap dispenser. And you see just a regular soap dispenser in a bathroom, and you see a dark-skinned hand come up and no soap. Right. So he takes try to take something without PII on it over here. It's like,
yeah, exactly.
There we go. It's in an envelope. It's safe. So he takes a white paper towel, puts it under, and gets soap. So the first question I always ask is, well, did the engineers who designed that soap dispenser, are they racist? course, the answer is no. They did not intentionally create a whites only automated soap dispenser. So what did they do? What is the mistake? Well, first, it was probably a bunch of white bros, tech bros, who were sitting around, and the first one got the soap dispenser to work while they're building it in the lab. He's like, hey, Chad, because it's definitely a Chad, come on over here and check it out. And Chad comes over, and Chad's like, this is awesome. And everyone's like, great, let's ship it. Mm-hmm. So we have an unconscious bias. What we don't know, what we don't know. And then we have a flawed training data set, right? At the end of the day, even if it's artificial intelligence, and Jake sort of put the eyebrow up with machine learning. So for the purposes of this meeting or this webinar, we're not going to get into AI versus ML. It's good enough to just be a general category for what you're going to be doing, because we're giving the practitioner's view, not the academic view. So we don't care. And so even in artificial intelligence, it's still the computer doing exactly what the computer has been told to do. So the AI, as it's been trained, is all it's going to do. And if the AI doesn't know better, then the AI doesn't know better. It's not going to be smart and figure that out and fix that. So that training data and those biases are the key element to making sure that you created something. Now, once we put something in the loop, because we have that famous story of the Microsoft AI chatbot being unleashed on the internet, and the internet within 24 hours turned it into a Nazi.
Good old Tay.
What's right? That?
Good old Tay.
Yeah.
Yeah, Tay.
It's because the computer is only going to work with the data it has. And so it trained on Nazi data and it became a Nazi, right? So there's this concept in offense we call execution guardrails, right? I want to make sure my payloads don't operate out of where I want them to. This is how Stuxnet got caught. It executed somewhere it shouldn't have. Well, same thing with artificial intelligence. I need to establish parameters where there's a flag that goes up and say, human in the loop, we've got something out of tolerance that we didn't expect. Come and check this out. Now, obviously, the racist soap dispenser is a silly story that's more metaphorical, but you start taking that from just dispensing soap to where there is the question of where AI can have real impact in the real world, and suddenly it's not so funny.
Yep. Hey, I've got a screen share up from a keynote I gave a few weeks ago. Can you promote that up there? Because I think it ties in very well to your racist soap dispenser topic.
I don't seem to have the ability to do anything with it. Ooh. I could promote you up. There we go.
Hey, there we go. And so awesome. Hey, thanks. I had no idea how to do it there. I guess that was probably yeah. Anyway, but that's a reality, right? And far too many dev shops. It's so funny that you brought up, right? They were probably all white tech bros, but this is what a lot of our dev shops look like, and this is where you're getting a lot of inherent bias, from is just that absolute lack of imagination, right? We're training it on, and that's not I don't mean that necessarily in a fully critical way, like saying, hey, these guys are fools or whatever. It comes down to when you don't have that diversity, right? You are very likely not thinking about edge cases that frankly don't impact your demographic, right? And so yeah, that's honestly one of the biggest problems in AI, honestly, in AI safety today is unchecked bias, right? And of course, when we get into bias, like then there's you can't get rid of bias in AI, like it's just not possible. At best, we're looking at harmful bias, right? Which of course is use case specific. So anyway, so I just figured I'd throw that up there since it was already here and had it available there and ready to go. But hand to heaven, we did not rehearse that, the racist soap dispenser thing. I just happened to have this, from that keynote a couple of weeks ago.
Jake, I think anyone who's ever seen me speak knows that it is all improv and off the cuff. There's
there's no rehearsing.
Zero planning. Yeah. It's just what you see is what you get, which is part of what makes it fun because you don't know. Yeah. Neither do I. Like I said,
I may zig left or zag right. We'll decide on the fly, right? So yeah.
All right, so we've gotten to the definition and the risk. And by the way, back to where I frame that risks, there's a great document by NIST, AI 100-1. It is actually a good document. For those of you who know me, do not give quarter to the government just because they produce something. If it is bad, it is bad. That document is actually pretty good in terms of looking at policy and recommendations for how to structure an AI policy for your company. So now that we've gotten that foundation out of the way, let's start talking about what it actually means. So how would you summarize AI's current impact?
Woof. Lots and lots of exploratory work, trying to fit square pegs into round holes, honestly, right? I'm doing a bit of AI development already for a couple of different clients. I've got a large language model application pen testing course, you name it, right? So, like, I'm seeing a lot of folks getting into and asking for security consulting around, both building AI applications, right, and then testing them for security. One of the problems we bump into, though, right, is that so many folks have not threat modeled through their application and don't understand, like, they're getting to the end of dev and then realizing they can't ultimately create this in a secure way, right, for whatever their particular constraints are. um, you know One of the big things we keep harping on, right, is like the non-determinism of large language models. So non-determinism meaning for a given input you don't always get the same output, right? And it's not like, you may in some edge case get some different output. It's like every output's different, right? Well, that creates a lot of problems from a security perspective because we kind of rely on consistency and determinism, and so, um, yeah, there's just a lot that we're working on with that, and I think those are probably some of the biggest problems here. Is that it's I've seen a lot of use cases where folks are trying to, again, fit square pegs in round holes because AI is the new hotness, and they're being told go forth and develop AI. Um, are you familiar with the Klarna case study? Klarna, the buy now, pay later. So they talked about, like, a year and change ago, right? Went on the road with OpenAI and talked about how they're saving, like, I think it was like something like astronomical number, like $700 million on, staffing costs over the next 3 years, because they've built this AI chatbot agent that has higher satisfaction scores than most of their human agents.
I don't know the case study, but I know how it ends.
You do know how this ends, of course, right?
No, I could
So,
guess. You've already given me the setup.
yeah. Well, but I should mention here, yeah, of course it explodes. Yeah. So it's funny because that was again year and a half ago, right, on the road with OpenAI. Um, and just in the last couple of weeks, the Klarna CEO is up there. He's like, I think the best, speaking at a conference, like, I think the best use case for AI is connecting our customers to the right human agent, right? And it's like, okay, right. Look, all that said, right, there are fantastic use cases.
Every automated phone system ever that you want to throw out a window.
Dude, tell me about it, right? But I mean, a lot of folks, like, read the case study, and they say case study, they read the success story without following the how did we get here, right? And so, they're like, oh, we can replicate this with a chat bot. It's like, probably not, right? Air Canada, right, famously had that issue, where, you're familiar with the Air Canada story where it, like, hallucinated a refund policy, then they wouldn't honor the refund policy. And so the gentleman took them to court, right? And unsurprisingly, their disclaimer does not matter, right? The little disclaimer that says verify the output, right? I mean, I'm not a lawyer, and this is legal advice. Talk to yours, right? But yeah. Anyway, so again, lots of great failure cases. We have some great success cases too, though, right? Where folks are using generative AI for fantastic, like, semantic search use cases. Like, I love Copilot for M365. I regularly, when we talk at conferences, I'll ask and say, like, how many folks have used SharePoint search? And I raise my hand, and of course, a bunch of hands go up. And before anybody can put theirs down, I'm like, who's used it successfully, right? I drop my hand. Everybody else drops a hand too, and get a good laugh out of it. But, like, SharePoint search is abysmally bad, right? And then we roll over to, Copilot for M365, and it's a fantastic tool for surfacing the data that I already have access to. Um, Double-edged sword, though, right? Because, the security foundations of Copilot for M365 are entitlements management and data sensitivity labeling, two things that we have historically been really, really bad at in security. So, win a little, lose a little, right?
That's a good segue into the way I classify artificial intelligence. Is
Mhm.
we are what we'd been through from about the 60s to just recently was a data revolution. Data could be easily captured, data could be easily shared, hence the internet, hence modern business based on information technology. We are now on the cusp of a knowledge revolution.
Mhm.
Data has no context. With artificial intelligence, we now bring context to data, which allows me to interact with it and slice it in ways that I hadn't considered. I don't need to do that, right? I don't need to have built the SQL query for something. I can just say, I want this thing, and it figures out how to do that, and it takes that step out of it. And for us as professionals, and this ties to what Jake was just talking about with the risks with Microsoft Copilot, is the security we provided in a data environment was simple: roles-based access control. You with this role can access this thing. And I say simple, and yet look how much we struggle with it, right? Now we've made it exponentially more complex, because now the challenge is not me controlling your role to get access to data, because all of the data is available in the lake for the artificial intelligence to query and to understand. Now I need to be able to put bounds around where it crosses contextual understanding. The CEO saying, I'm interested in our finances, should get a different response than a contractor who has access to the system saying, can you tell me something, right? That's the new security challenge that we have as professionals. And the fact that we couldn't even label the data in the beginning, let alone labeling the data to understand the context of the data in a number of ways, is the current challenge in our knowledge revolution. But I do want to really frame that. It's a knowledge revolution.
Mm-hmm.
All of the spaghetti you are seeing thrown at the walls of how to use artificial intelligence are all applications of knowledge management. Nobody has built anything today or is imminent to building anything today that is anything different than that space.
Yeah, I love one of the things you kind of pointed out there too, right, around like data classification, right? This is a place where I think generative AI is fantastic. There are a lot of folks that, and I've been guilty of this myself, right? Where I'm like, well, it's non-deterministic. I can't always verify the results. I can't, man, even if I take an arbitrarily low number and say the artificial intelligence fails to classify the data appropriately, some astronomically bad number, like 30% of the time, right? Okay, cool. That means it worked 70% of the time, which is still better than the vast majority of enterprise data classification programs. And so the ability to use tools like this at scale, one of the things that I kind of highlight is, right, you got to look at what your failure cases are and then understand both the failure rate and the impact of those failures. If the impacts aren't catastrophic, then rock on. This can be a fantastic enabler for taking on something like, again, just as mundane as data classification.
I'm going to throw up a comment here from the audience. So one of the challenges we have is, like I was talking earlier, they're trained, which means a computer doesn't understand the context other than what it's been trained on. And it does it with completely straight face, whether it is right or whether it is wrong, and you have no understanding of that. Part of the answer here is going to be how we have experts in the loop, because I'm sure a number of you have seen how you can use artificial intelligence to programmatically generate code, for example. Well, coding traditionally has been the provenance of trained experts, right? No, not just anybody can develop. It's a hard thing to do. And so now you have the two use cases for that are an expert using something to get them started, or a novice trying to get something without it. And so this ties in the hallucination category, because the code is going to have failures. The code is going to not do what it's supposed to do. And there's going to be an increasingly bigger problem with that the more complex the code is. The second is in this note here that from Vic. So hallucinations seem more solvable, or at least making it easier for the user to identify, by having the AI provide citations. So this gets to one of the other challenges we have with artificial intelligence is it's a very black box. It gives you an answer. How did it arrive at that answer? What sources did it consider to arrive at that answer? Now, having real world sources, which I'm going to bet you it's not going to be more than a week before we already have an example of a hallucinated AI provided citation as well. So it's going to,
I've got them. I listed this, right? Yeah.
Yep, go for it, Jake.
Oh, no, I've got lists of like like AI will hallucinate the actual citation itself, right? Grok is a little bit different because it's doing a search first. It's less citing the source, right, as much as it is using retrieval augmented generation, right? So Grok is actually doing a web search first through whatever search engine. I actually don't know what Grok's using on the back end. Probably something developed at X. But it's doing the search first, and it's bringing in that context, writing the response, right? You do have a garbage in, garbage out problem here, though, right? With like you have with any retrieval augmented generation system, if the search results are bad, you are effectively poisoning the well and giving the LLM bad context, right? So yeah, I mean, but yeah, we have I have had multiple people reach out to me asking for slides about a webinar that I never gave, right, with SANS. And it's on detection engineering, right, with Symantec. So I did lots of webinars for SANS, like in the probably triple digits over the 10 years I worked with them. I did several on detection engineering, and I work with Symantec. All of those things collectively are true, right? But ChatGPT, for whatever reason, has hallucinated that as hallucinated content from it for, again, what reason I do not know. But I've had multiple people reach out to me asking me for these because they're doing like college homework or whatever, trying to get these slides to go cite. And again, it's an event that just never happened, right? So like firsthand, I can speak to that, unfortunately.
So we're going to segue that into this question. So do you have an AI risk assessment approach, or how do you get the risks for AI in a pragmatic way? So the part of why I told the racist self-dispenser story is it anchors the two categories, the training and then the execution. In addition, there's another component of this, which Jake's touched on already, which is the security of the system itself, and then the data controls within the system to ensure appropriate role context access.
Yeah. So, yikes. Do I have risk assessment approaches? Yeah, totally. First off, if you want to do a risk assessment where I had to develop this for a client, I've got a framework called Risk AI Assessment. And so if you go to riskaiassessment.com, let's see, I guess it just redirects over to Hunter right now. But like we'll happily drop you the slides for that and the write up and whatever. So I've got a framework there, and that's really designed to help you prioritize your very, very limited resources, right? With all of the apps that are including AI. If you're building your own apps, I really am a big fan of the DOE AI RMP. If you go Google for that, unfortunately, you will not find it, or you'll be given dead links because it does mention diversity. And as a result of policy changes, right, it's been removed from DOE's website. The good news is the Wayback Machine never forgets. And so you can go to the Wayback Machine and get the DOE AI RMP. And I think that's a fantastic, both not just a risk assessment framework, but also like recommendations of controls, right? For addressing every one of the, I think it's 141 or some odd risks they identify across the entirety of the AI lifecycle, from problem identification. And by the way, they have the best documentation on, is this a good fit for AI, right? Is my use case a good fit for AI? It's fantastic. So anywho.
I'm going to just throw up this on screen. There's a game called Gandalf made by Lakera. That is a really fun way to practice prompt injection. So it can teach you how to fool an AI. And it goes through successive levels, and the AI learns as you go. So it's a good feeling to sort of understand that context and that controls, trying to get access to sensitive information and having the AI tricked to do that.
Yeah, definitely. Yeah, no, I like that. The prompt injection piece is interesting, right? And this is something that I keep talking to folks where they're asking me, like, how do you protect against prompt injection? By the way, for folks that don't know, prompt injection is, you can think about it like cross-site scripting almost, right? You are cross-site scripting. We confuse the browser, right, to treat data as code and execute it as code. In prompt injection, you are tricking the large language model into interpreting context or data as instructions or code. And so people have been asking me, like, how do you prevent this? And I, I've done a lot of research on this. And in fact, that's my big machine learning workstation behind me, Colossus. I came to the conclusion, probably late 23, maybe November, December of 23, like, this isn't a fixable problem. Like, there are lots of things we can put up roadblocks to make prompt injection harder. We can't fix it overall. And I've had lots of folks fight with me on that take. And then Mark Russinovich, right, who way smarter than I'll ever be, right, stood up on stage at Ignite last year and said exactly the same thing. And I'm like, rock on. Okay, now we've heard it from the man, right? Yeah. So again, something we can put up defenses around, but at the end of the day, right, you have to treat the output from your large language model as you bring it into your app as not just untrusted, but hostile input. And if you threat model like that, right, you generally eliminate that as an issue. But anywho.
So we're security practitioners. How should we use artificial intelligence to help us do that today?
Do security practitioner work today? So I think there's a lot of different places you can use it, right? Summarizing data, certainly, right? Getting ideas. One of the things I demo at a lot of the IONS conferences, right, is I walk through an example, right, just with like regular ChatGPT, where I'm like, hey, we're a proof point. We use Proofpoint as a SEG and ITDR. We have CrowdStrike as our EDR, right? I walk through a control stack, and then I say, hey, we got hit with a phishing email that delivered a HTML smuggling payload that ultimately executed mshta.exe. What should we do for response options? And I use that intentional straw man, right, to show and say, do you think any of this data is sensitive, right? Do we have anything here that we can't reveal to a large language model? Are we worried about data security here? And consistently people are like, oh my gosh, that's so sensitive data. And I'm like, your entire control stack is in your job, it's in your job postings for security team, right? So that can't be sensitive. We got hit with HTML smuggling. That's everybody every day. And so, as we then look at the output of it, right, the response options are honestly, and kind of framework checklist type stuff, it's honestly better than what I see out of a lot of security ops centers, right? So, SOC analysts. And so I think that's one of the big places that we can go. Another big one, me and Mick Douglas have talked about this one a lot, is that the difference between a level 1 SOC analyst generally and a level 3 SOC analyst, beyond obviously the experience side, right? A lot of your level 1 SOC analysts know what they want out of our tools, whether it's EDR, SAM, et cetera, to query out of the tools. They don't know how to get it, right? And so large language models and AI break down the barriers, right, between knowing what you want and knowing how to write these ridiculously complex, queries with compound conditions and, knowing what fields to search for. So I hate the term, but it democratizes that a little bit. So, I mean, those are some just right off the bat, places that we can use it. But you're not going to automate your security team away. I think that's another important thing to note. The people who are promising that are selling snake oil.
So that goes back to the way that I phrase the current revolution is it's one of knowledge management. So what you described is knowledge management use cases within a security operations setting.
Yes. Yep.
That's what we can expect to have happen. And it's worth noting, I mean, short of the dark trace comment, we've seen artificial intelligence in security actually for some time. A lot of your SIMs have already been using anomaly and pattern matching, where I don't have to have a human threat hunter go in to build a hypothesis query to test against the data. It's just doing on its own, going, what do I think baseline is? And then querying anything that it thinks to understand across of what's outside of baseline. Now, recognizing that there's going to be limits to that because you're going to have quantitative pattern matching that if there's enough randomness, enough jitter, enough of that anomaly being difficult to not have a simple pattern to identify, it's going to struggle to do that, which is where a threat-informed query from a human is still necessary to apply the threat intelligence.
Yeah. No, concur 100%. Well, you said threat intelligence. What another great, use of, use of generative AI, right? I'm not interested in summarizing a threat intelligence report. That I think is a horrifically bad, because with horrifically bad use case, because, with intelligence, the devil is in the details, right? And reading the Cliff Notes, I mean, look, I don't want to, guess what Bryson did in school, but I'll be the first to admit that there were probably a couple of books in Lit that I didn't actually read. I read the Cliff Notes instead and prayed that would be enough to get through the exam. And sometimes it was, and often it wasn't. And, same thing with CTI, but often I have multiple reports from different, from different entities. And look, I could consume all of those and try to find the unique reporting, right? But this is a fantastic spot for Gen AI. If I already have, a report on, a particular threat actor, I can provide that as context to the Gen AI and say, what does this new report, right? What this new report that I've seen, what's novel and unique in this new report, that's adding to my knowledge, right? And this, again, we're coming all the way back around to what Bryson started with this is a knowledge revolution, right? Whereas previously you'd need to spend the time to read all that, hopefully keep in your working memory what you already knew, right? And then extract those new and novel things. Again, this is something that itself can be automated quite a bit. So, yeah.
Jake, you've known me for long enough. You know I never used Cliff Notes. I read everything.
Yeah. Okay. Fair enough. There were several of them that, I mean, like just stuff I generic. I'm sorry, just generic. Was not.
You don't have to excuse what your study practice from 30 years ago.
Yeah, I'm more than okay admitting, right, that I made it through, a couple of classes that way. But I also wasn't interested in English lit, so in the least. Yeah.
Okay, so I like this one. We were talking earlier about the fact that it's the training data. Well, this gets into a policy question. This gets into an intellectual property question, and there's already numerous lawsuits on this because at the end of the day, the tech company approach has been, hey, if it's on the internet, it's free, and therefore I can use it to train with. And as we've described earlier, we also have a problem because the internet doesn't actually represent a completely perfect training data set. It's just a very large, easy to access training data set. So you have challenges inherent in that comment. The projections that I've read is that we will have run out of all of the data that is currently available by 2026 to train AIs. So we are already running out of the limit of data. One of my forecasts, if I'm putting a prediction, is there will be a startup market for creating data. So that's going to be an entire startup genre.
Okay. I'm not sure that I don't disagree with you there, right? But that's largely going to be synthetic data creation. The issue is not, look, we've already hit a peak. And by the way, let's back up two steps here, right? As we talk about training data kind of running out as it were. One of the reasons, like these generative pre-trained transformer models they're not brand new as of like a year or two ago, right? What changed here in the ability for us to do this predictive text is GPUs, right? We hit a price for performance spot. I mean, like I remember working at Institute for Defense Analysis. My first experience with AI machine learning was back in 2008. But they had crazy supercomputers, right? I could do stuff on those that I can't bring to an average processor, and now you can, right? Now we have these GPUs. Like I've got 2 GPUs in Colossus back there with 48 gigs of VRAM a piece, right? That's like a few years ago, 5 years ago, even, like the idea that I could have that at home would be insane, right? And so as computing has increased, right, we stopped focusing as much on algorithmic efficiency and started focusing on bigger and better models, right? Or more accurately, bigger models, right? Creating better representations of data. And look, we've already hit that plateau where adding more data is not actually getting us better outputs, right? And so given that we've already hit that plateau, honestly, it's not about getting better quality data, right? Because as the person who notes, I think Greg here, right, with AI generated slop, yeah, totally. This is AI like left unchecked. This is AI eating its own tail, right? But part of the way you address this, right, and it's already being addressed, right, is like, for instance, authoritative sources like Wired, New York Times, et cetera, right, where, and I'm not going to get into the ethics of obviously using all this data unlicensed, although it's wrong, it's just wrong. But ultimately those get weighted much higher than like random sources like Reddit. And if you don't do this, right, see also Google, you end up, with folks Googling something and getting, in the little headline there, recipes for spaghetti sauce that include glue, right? Or what have you, because they grabbed some garbage data off of Reddit. And so again, the problem is not more data; it's higher quality data.
Again, going back to the data itself, right? You need both the breadth of it and you need the specificity and correctness of it. And we've seen this on the copyright side, where folks who have high quality fidelity data now recognize the value of that. And maybe that's where journalism will find its money again, because obviously the last 20 years we've seen a shift in mainstream media because of social media taking away from that, whereas mainstream media was high fidelity research cited sources for analysis. And that now is going to be more valuable in the future as we need it to train these things. Of course, somebody's going to build the reporter that is an artificial intelligence to replace the reporter, but that's what we'll get to that down the line when that's a problem.
Yeah, and we get into again, one of the biggest problems we've seen in artificial intelligence over the years, and also, honestly, one of the reasons that we haven't seen as many security use cases for AI. Like, I remember 2014, as I left the military, was working with the Mayo Clinic. Right, they've got 2 Cray supercomputers. Right? They're like, hey, you can have supercomputing time. Let's go crunch lots of security data, right? And we'll go find bad guys. I said from the get-go, like, your number one problem, I don't need the compute. I need to normalize this data.
Yep.
Right. And they actually understood, because we used a bit of a paradigm there that's very familiar in healthcare. There's an entire field of people whose job in healthcare is purely to clean data before it goes in for research. So like when you go in and get cancer, get cancer, you get cancer treatment, right? A radiologist, or
you heard it here first. Jake said AI can give you cancer.
Oh, definitely. Of course it can. Definitely brain cancer, right? But your oncologist or radiologist reads those imaging results. There's only one standard that they code against, and they still F it up, right? To the point that these hospitals pay people called cancer registrars, whose only job it is, right, is to go in, look at the data, make sure that the data is appropriately labeled, cleaned before it gets submitted in, to these machine learning algorithms, so that they can go find cancer clusters, figure out the most, effective treatments using Bayesian inference, you name it, right? Which are all different machine learning, types of models here. Again, at the end of the day, though, the fact that we're still paying humans, right, to go curate this data that, again, only has one format, only has one standard, and we still can't get doctors, right, to do it correctly, tells me everything I need to know about job security for at least the foreseeable future. When it comes to AI.
That's how I felt about security. We're never going to solve it, so it's permanent job security.
Oh, absolutely, right? Absolutely. And even when folks are like, hey, we're going to automate our way out of this problem, right? They're creating brand new security vulnerabilities with AI. Rock on. Love it.
Hey, more code, more security requirements.
That's it.
More surface area.
Oh, yeah.
So let's get a little specific on the spicy. Are there particular AI companies or AI tools you like and don't like?
Ooh. Yeah. So let me start with, I think Copilot for security could be an amazing tool. It isn't today, right? But it could be an amazing tool. It needs more transparency, right? There's, I think, but it ultimately could be an amazing tool, not today, because it does screw up a lot of stuff where it's not using Microsoft, their plugins. Microsoft calls them skills, right? Part of the problem is I don't always know what skills are available, what I can trust the AI to do and not. And they glue that together with an LLM. When they don't have a skill to go run something, a plugin to go algorithmically process some data, then they just tell the LLM, like, oh, okay, you figure it out, right? With horrible results typically, right? So tools that I really like, honestly, and this is probably going to be a really spicy take, I think the DeepSeek R1 model is amazing. Now, big caveats here. You should not be using DeepSeek, right? The API, the
back up on the why.
app.
We're going to have to give it context just to be sure.
What's that?
Why is DeepSeek problematic? Why should you be not using the cloud version of DeepSeek?
Yeah. And by cloud version, I mean DeepSeek hosted version, right? Because it is, the DeepSeek model is an open weighted model. It is available like in Azure Foundry, in which case, like, rock on, that's perfectly safe. Or safe as any other model hosted in Azure Foundry. Yeah, DeepSeek is a Chinese company, right? And they use ByteDance. You may remember them from the TikTok scandal. They use ByteDance's data centers to host their models in China, right? And so, you might as well just figure that you're handing your data over to the CCP anytime you're using the app. But DeepSeek R1 is, and yeah, that was a great question. I do appreciate that. The DeepSeek R1 reasoning model is absolutely amazing. I'm able to get the 70 billion parameter model running in the one of the 48 gig cards. So I should mention here, the performance drops off a cliff when you go down to the 32 billion parameter model that you can run like on a NVIDIA 4090 or what have you. Drops off a cliff, right? And so these aren't consumer grade cards that you run it with, but one of the reasons I like it is that it shows full chain of thought. It's what's called a reasoning model, right? And it iterates through on chain of thought. OpenAI doesn't do that, right? Now, in fact, when they released the O1 model, which was their first, publicly released reasoning model, anybody that tried to do prompt injection to like leak chain of thought, they were targeting and threatening to suspend their accounts, right? So go ahead, ask me how I know. But we're targeting folks and threatening to suspend their accounts. When DeepSeek released the R1 model, OpenAI did an about face and said, well, we now are going to make more of that reasoning data available. Turns out they still filter a bunch of it, which honestly may be worse than not showing it to me at all, because they're showing me a summarization of it, and it's often not correct. But the big deal here, right, with DeepSeek is for the prompt engineering side, right, and debugging prompts, it's no longer a black box of, I mean, there's still a bunch of black boxy stuff to it, right? But I'm able to see how DeepSeek is reasoning differently based on different language in my prompt versus just submitting the prompt and seeing the output. With OpenAI and Anthropic, that's all I can do, right? Now, again, both of them are showing more reasoning. I don't think either of them are showing full reasoning yet. And so that was something just like wildly helpful with DeepSeek R1.
So the innovation of DeepSeek, for who aren't aware what's going on in the greater industry, is that artificial intelligence has created an exponential demand for energy because of an exponential demand for compute to be able to do all of this. So it's a very expensive operation. Most of the work had been on just expanding the corpus and the functionality of it. DeepSeek's great innovation is they said, hey, you know what? You don't need hundreds of millions of dollars to do this. We'll do it on less than 5 million. And we'll be able to use a fraction of the resources by having an innovative way to kind of cut corners on how the AI needed to have its knowledge base and being able to track context for that. That was the big innovation with DeepSeek and why it has disrupted the current landscape.
Well, yeah, not only that, but like their academic paper talks about how it actually did there were some emerging behaviors that they did not program in it specifically with like obviously the chain of thought, like the doing chain of thought, right? They programmed in, but it actually does some back looking analysis, right? To go and recheck previous assumptions made, and that's not something they programmed in. That was just emergent behavior. I strongly suspect that when Sam Altman in December was presenting a conference and saying, we know how to build AGI, I strongly suspect that OpenAI has seen similar things, right? And was calling that like, oh, that's the beginning of AGI. It's spontaneous behavior, right? That we're, that we're observing. And of course, we all know this is just math. It's just math, right? And what's that old quote? Any sufficiently complex technology is indistinguishable from magic. Yeah, right. Still exciting nonetheless.
So what are some other products you like and don't like?
Oof.
Yeah, you only gave me one, so DeepSeek wasn't enough.
Yeah, so some other products I like, Llama Guard, right? I'm a big fan of Llama Guard from Meta, or at least the idea of the framework, right? You can adapt your own framework there. I love that for like, the example you used with Tay earlier, where it started, denying the Holocaust and writing Nazi fan fiction inside of 24 hours on Twitter. It's very difficult to as I'm sure everybody's aware here, just to filter on specific offensive keywords. I could say, well, don't use the word Nazi, right? Don't say, whatever. And folks will come up with coded language for that, right? Like the 1488 folks and the, you name it, right?
Or Winnie the Pooh in Chinese social media.
Fantastic example, Winnie the Pooh, and yeah, totally, right? Which is code for good old President Z. And so, the the reality here is that Llama Guard helps us, instead of doing like regular expression matching and saying, hey, that's a harmful term, right? It looks and does overall classification of a response, right? And says, oh, that involves advocating for self-harm, right? So we're not going to return that to the user, right? We're return some other, other response to the user. One other tool that I'm a big fan of is Microsoft's Presidio. That's an SDK, right? And there's if you're interested in like a pre-built-ish kind of version of this, there's a company called Witness AI that builds this in to some of their applications, which is, they're really kind of CASB-like, if you will. But ultimately, I like Presidio because it allows me to preserve context of sensitive data, right, without actually ever passing that to a large language model. So if I'm using an externally hosted LLM, even though hopefully I have contractual controls around what you do with my data, I can have it go like, it says, Jake dialed this number and then talked to Bryson and they agreed to do lunch, right? It uses something called named entity recognition, which is also machine learning, to go and identify in that prompt and say, Jake, person one, right, dialed phone number, and literally replaces it with phone number one, right, to talk to person two, Bryson, right, and it passes that to the LLM. Well, the LLM operates and says, oh, okay, well, person one, right, person two, phone, to the extent that that's relevant in the response, Presidio can intercept that on the other side and replace those, right? So I not only get to it's basically like a PII tokenization framework. So I get all the benefits of maybe processing some data with generative AI while tokenizing the data before it goes, programmatically tokenize the data before it goes to the AI. So those are a couple of tools I'm like, I don't know, I'm kind of stoked about. So yeah.
So we've talked about hallucinations. We've talked about emergent behavior. Part of emergent behavior is scheming, where an AI just decides to start HAL 9000ing itself into the direction it chose is the best way to go.
Yeah. So this is not a new thing, right? And by the way, the word for scheming is reward hacking, right? The technical term, right? The machine learning or academic, that's where the academic term is reward hacking. Every AI has in order to, like, because again, it's all math, right? I love, by the way, I'm going to segue here for a second. If you haven't seen Don't Look Up, 100% love that movie. My favorite line in the movie is they're like, go brief, and but try not to get into all the math. And he's like, but it's all math, right? This is all math. And so look, at the end of the day, artificial intelligence is intelligent because we tell it to maximize around a particular reward. And we have seen from the earliest days of AI in the 70s, right, all the way through today, right, with scheming, ultimately the AI looking for finding unanticipated ways, right, unanticipated from the human perspective, ways to maximize that reward function. The problem here typically is not the problem here is typically not the AI. It's the fact that we as humans are bad at approximating that reward function, because that reward function is standing in for something that, our desired outcome, right? And we just overgeneralize it, and the AI then, so a fantastic example of this, like there's a story going around where, to win at chess, right? The AI, ultimately, went and edited a text file that had the board positions and won that way.
It cheated.
Yeah. Now the devil's in the details, because as you go read the actual, not the headline and not the article in the Register, not the You go read the academic paper, you learn that they pointed the AI to the text file. They explained this was a way to cheat, right? And but did not leave it out as or did not exclude it as, in the instructions as something you should not do. They said, go win the game, right? And so this one's a little bit, I don't know. I think if you tell it how to cheat and then say win at all costs, right? Then that is part of the rules, right? Rules as it were of the game. We haven't really seen a lot of, that I'm aware of, at least. I haven't seen a lot of good examples of like broad-based scheming by AI agents, right? But I should also mention, in large part, that's because we often don't deploy AI agents, with like autonomous access to a lot of stuff. So we'll probably see it more as time goes on. But the long and the short of it here is that's all stuff we have to threat model. It's all stuff we have to create guardrails for. If you want to read more about this, just Google the paperclip problem, and you'll get some good background on reward hacking. So.
Okay, the last question is gonna be the hardest question.
Oh,
I know. I like that you know me well enough to be like, oh no.
Yeah. Okay, go ahead.
So I gave a keynote at ISC Squared in 22 on artificial intelligence, and I had a part of it where it starts with just a little black rectangle, and the little black rectangle becomes a little black square. And the little black square eventually grows into a generic person profile. And my point of all of that is we're going to continue to see incremental innovations and growth in artificial intelligence until one day humankind changes forever and we wake up and it's enough of a person that it matters, right? We're no longer on the knowledge management revolution. We are now into generative artificial intelligence. What is your guess? When is that going to happen? What's that going to look like?
So we're talking AGI, right? So general human level intelligence. We're at least a revolution away from that, right? So I want to be clear here. I do not believe that LLMs are the right answer to get to general intelligence, right? OpenAI is betting the farm on this, like to the point that Altman went out and talked about like needing to build their own GPUs and trillions of dollars in investment and what have you. I'm not buying it. I don't think that's. I feel like we're kind of in a space today where, pardon the pun here, we're in a place today where we're saying, hey, we're going to build bigger and better passenger planes, and that's going to get us to Mars, right? And it's just not. Like, they're related fields, aerospace and space travel, but they are, incremental improvements in one, may contribute to another, but it doesn't get you there, right? And so we're at least another, like GPTs were a revolution. We've known how to do, the, text generation, right, for decades. The difference here was optimizing it, right? Of course, hardware scaling to work with it too, but GPT, generative pre-trained transformers, they were a revolution. We're at least another revolution away from that because there is no independent, like we see some emergent behavior, right? But there's no true creativity there, and that's not going to get us to AGI. So 10 years plus, right? The people that are talking about this like on a 3 to 5 year horizon, I think they're delusional, right? Because they're all talking about how we're going to, well, some of them are delusional. Some of them are snake oil salespeople. Some of them have big financial benefit or financial investments to protect. But at the end of the day, it's going to require some real academic revolution to get there.
All right. Well, Jake, thank you. I think that we have covered all of what you need to know as an introduction to artificial intelligence, where artificial intelligence can and can't help you today, how we as security practitioners can use it, as well as how we can defend it and what's next. Any final thoughts?
I'm going to tackle that quantum question in there, right? My friend, we know nothing about, we do not understand the physics of how quantum computing even works. Right? When you hear Google talk about quantum supremacy, they are solving a problem, specifically a problem with no actual real world use, specifically built that a quantum computer can calculate. at least the ones we're building today, that general purpose computers cannot. Right, so they are. It's kind of like winning a I don't know if you watch The Office, right, where they have the Office Olympics, and Kevin's like, "Look, I put the most peanut M&Ms in his mouth," right, and he's like, and Jim's like, "No one else should even try," right? You're winning a contest that doesn't matter, right? Now, I'm not poo-pooing quantum computing. I think it's a fantastic thing that may eventually come, but you need to understand how little we understand about the physics, so much so that Google, in their last post where they talked about quantum supremacy, right, they talk specifically about how their research to date for Willow, their new quantum computer, leads them to believe we live in a multiverse. My friends, I uncritically said, yeah, anyway, I regularly analogize this to if you didn't understand the physics, right, and I told you that I was going to take flight by flapping my arms, and every day I went out and I jumped a little bit higher and a little bit higher, you would say these are promising results, right? Because Jake is making incremental steps towards taking flight. Now, you know that's ridiculous because you understand the physics. I will never take flight by jumping and flapping my arms, right? We don't understand the physics here. So to the extent that this might help with AGI, right? Great. But that's something that we are way far away from even understanding how it works, let alone building general purpose quantum computers. Anywho, sorry, that's a pet peeve of mine when folks get on quantum, and no offense to Josh here, right? But again, lots of folks are buying a lot of hype there too. That's yes.
Quantum solves O of n in compute. Quantum doesn't make it better.
Yeah, that's it. Yeah.
Yep. I'm the simple one. Not a lot going on. And that's what you come in for every month on Unicorn Dispatch Live. So we'll see you next month for the next one.